Stratovolcanoes. You may have seen one recently, such as the San Francisco Peaks in Flagstaff, Arizona. This mountain's a bit of an anomaly because most stratovolcanoes are located at tectonic plate boundaries, especially where a dense ocean plate collides with and is pushed beneath a lighter continental plate, being recycled deep into the earth at a feature called a subduction zone. As the ocean plate subducts, water driven out of its minerals by increased pressure helps to melt the surrounding rocks, creating magma that rises to the surface to form a chain of volcanoes. The Cascade volcanoes of the Pacific Northwest are an example of this process in action today. In fact, most of the Pacific Ocean is surrounded by subduction zones and associated volcanoes, the so-called Ring of Fire. Geological hazards such as earthquakes, volcanic eruptions, and tsunamis are concentrated at Earth's subduction zones. Perhaps you remember the 1980 Mount St. Helens eruption or the 2011 Fukushima earthquake and tsunami, both at active subduction zones, and just a few of the many human disasters that have occurred at this geologic setting. However, many important questions remain about where, why, when, and how subduction zones originate. Details of their early history are erased by later tectonic activity and erosion. Unfortunately, we can't ask the dinosaurs about this time, although they were around. To witness subduction nearly encircle the ancient supercontinent of Pangaea. The volcanoes from this time have long since eroded away. So how do we know they existed in the first place, and how can we learn more about early subduction-related volcanism? The answer lies in granite and sandstone, exposed in isolated areas of the Mojave and Sonoran deserts. The granite formed as magma chambers beneath ancient volcanoes eroded away, revealing the location of the ancient volcanic chain. The oldest subduction-related granite identified in this region was found in Sonora, Mexico, and is 275 million years old, suggesting that is when subduction beneath Western North America began. But because each granite must be analyzed individually to determine its age, it can be very costly to use the granite to study long-term trends in volcanism. So this is where the sandstone comes in. It accumulated in basins above the early subduction zone, incorporating sand from the erosion of active volcanoes as well as older rocks. By collecting Triassic sandstone near the ancient volcanic chain and determining the ages of the sand grains, I have learned that once subduction initiated beneath Western North America, there was continuous volcanism for 30 million years. These results have implications for modern subduction zones, such as the one forming on the southwest island of New Zealand today. Only time will tell how subduction zones continue to shape our Earth. But one thing is for certain, with millions of humans living in the shadow of subduction zone volcanoes, they certainly will affect our future.